Hello and dear viewers, I welcome you all to this current episode wherein I am going to discuss about the landslides. And I remember this is the topic where I have concluded in my earlier episode. So, friends, with the intention of giving deep insights to the current aspect, I am with the intention of going in detail with each and every aspect. So let us jump on to the current topic, that is landslides. So friends, landslides, they're also called as the slumpings or the slidings also. These are very rapid kinds of movements and occur when a large mass of soil or rock falls suddenly. So landslides usually occur on steep slopes, of course, such as in mountainous areas, on cliffs, or where man has artificially steepened slopes. And for example, in roads or rail cuttings, etc. Of course, landslides may be caused because a steep slope is undercut, maybe by a river or the sea, so that it falls by gravity. Earthquakes or volcanic disturbances may loosen rocks and start off a landslide. Man made steeping both undercuts the slope and sets up vibrations which may loosen rock or soil. But often landslides are caused by the lubricating action of rainwater. Water may collect in joints or bedding planes in rocks so that one layer slides over another. And especially in areas of tilted strata, slumping is particularly common where permeable debris or rock layers overlay impermeable strata, of course, such as clay. Water sinking through the permeable material is halted by the clay, and damp clay provides a smooth, slippery surface over which the upper layers easily slide. And water may collect at the base of the regolith because it sinks readily into the weathered material, but more slowly into the solid rock beneath. The water may allow the regolith to slide away from the underlying rock, and man often enhances the possibility of landslides by clearing natural vegetation for agriculture or housing activities. Of course, removal of the plant cover allows more water to penetrate the soil and rocks. And in areas such as the Cameron Highlands, where steep slopes have been cleared, there is much evidence of minor slumps and slides. The old scars showing up clearly in the tea gardens. Extensive landslides, whether natural or man induced, can have disastrous consequences, burying villages, railway lines, or people. Spectacular landslides have taken place in many parts of the world, including South Wales, the British Columbia, Hong Kong, and the Cameron Highlands, where the village of Ringlet was partially buried in 1961 and several houses were ruined. Now, friends, we need to throw some light on the agents of gradation also. As a part of it, these agents of gradation, of course, they may be any natural agency that is capable of transporting the weathered rock material is known as an agent of gradation. And in this process, the running water, the groundwater, moving ice, glacier, wind, and sea waves are some examples of agents of gradation. So, friends, there is every necessity for us to have some deep insights with each of the aspect just I have uttered, right? And in this process, first of all, let us deal with the groundwater, which is an agent that is capable of transporting the weathered rock or the material, right? Groundwater. The whole process of circulation of water between the land, sea, and atmosphere is known as the hydrological cycle. It is known as hydrological cycle. The movement of water in the atmosphere and its effect on climate, or I think we have discussed in our earlier episodes. So we will not go in detail talking more about that atmosphere and water, etc. Right. Of course, with regard to sea and ocean, also we have a lot more discussion in our earlier episodes. Right now, let's confine ourselves to the effect of water on land as an agent of weathering, the erosion, transport, and deposition. These things, of course, these four things right now I uttered, they are the part of the curriculum for UG students also. So there is even necessity for me to give some deep insights with regarding to the weathering process and the erosion, the transport, and the deposition, right? And now, when rain falls on the earth, it is distributed in various ways. Some is immediately evaporated and thus returns to the atmosphere as water vapor, and some is absorbed by the plants and only gradually return to the atmosphere by the process of transpiration from the leaves of plants. Of course, we have dealt in our earlier episodes with regard to transpiration and all, right? Much of it flows directly off slopes to join streams and rivers, eventually reaching the seas and oceans. This is known as runoff. Okay, this is known as runoff. A considerable proportion of the water received from rain or snow, however, percolates downwards into the soil and rocks, filling up joints and pore spaces and forming what is known as groundwater. So I think you got my point. What groundwater literally means. It is nothing but a considerable proportion of water received from rain or snow, which percolates downwards into the soil and rocks, filling up joints and pore spaces, and ultimately forming the groundwater. And now, groundwater plays an important part in weathering and mass movement, and is also important as a means of natural water storage. And this re enters the hydrological cycle by way of springs. By way of springs. The amount of water available to form groundwater depends to some extent on climate. Basically, it is the climate which dictates or which directs how much water be available in the table or in the ground. In dry climates, much precipitation may be quickly evaporated into the dry atmosphere and a little moisture may percolate into the ground. Whereas, in very humid conditions where the surface of the ground may already be moist, much water may be moved as runoff. And in moderately humid areas, water both runs off and sinks into the ground. So the moderately humid areas are the best suitable areas where the groundwater collects more. Right. And more important, however, is the nature of the rocks and how easily they absorb and retain water. Friends, various rocks and soils differ greatly in their porosity and permeability. I think porosity is nothing but the spaces between the soil particles, and permeability, of course, it is one of the absorption process. Permeability, right? So, various rocks and soils differ greatly in their porosity and permeability, and the amount of groundwater present and the depth at which it lies are governed by various characteristics. And porous rocks are those like sandstone, which have many pore spaces between the grains, and water is easily absorbed by such rocks and may be stored in the pore spaces. And regarding the permeable or pervious rocks, and those are which they allow water to pass through them easily, and thus most porous rocks are also permeable. However, some rocks are porous but impermeable. And you can take a clay as an example, dear friends. You can take clay as an example. And this is highly porous since it is made up of innumerable very fine particles with more spaces between them. And it thus absorbs a great deal of water. However, the pore spaces are so small that the water does not move easily through the rock, and which is thus impermeable. That is the reason. On the other hand, granite, which is a crystalline rock and consequently non-porous, is often pervious, and its individual crystals absorb little or no water, but the rock may have numerous joints or cracks through which the water can pass, rendering it pervious or permeable. And some granites are, however, far more pervious than others, right? Friends, uh, let us discuss in brief about the water table, right? The permeable rock in which the water is stored is known as the aquifer. It is known as aquifer. The surface of the saturated area is called the water table. The depth of the water table varies greatly according to relief and to the type of rocks. Right. And here I can provide you beautiful diagrams regarding to this groundwater table and various things we have discussed regarding this agents of degradation, the landslides, etc. I think, friends, here we need to deal with things like the springs, the wells, etc. What they are, what do they mean? And of course, we may come across with various technical things like dikes, the stills, etc. We need not go in detail with regard to the springs and wells, right, friends? Now, it's time for us to move on to the another important topic, that is the landforms. The weathering process, ultimately, basically the soil formation process, uh, it ultimately leads to things like transportation and deposition. So, in this process, we need to deal with various types of transportations or depositions that are taking place in wind areas, the glaciers, the ice carrying areas, the groundwater, and the places with plenty of groundwater, and of course the running water. So all these things are all these processes. They give the scope for landforms. So in that process, first of all, let us deal with the various landforms that are made by the running water. Right. In this process, first of all, let us see about the development of a river system, dear friends. When rain falls, part of it sinks into the ground, and some is evaporated back into the atmosphere, and the rest runs off as rivulets, the brooks, streams, and tributaries of rivers, and which flow down to the sea. And this running water forms a potent agent for denuding the Earth's surface. Of course, denudation is the general lowering of the Earth's surface. This takes place because such agents of erosion as rivers, ice, wind, and waves wear away the rocks and transport the eroded debris to lower land or right down to the sea. But erosion cannot take place unless the rocks are first weakened or shattered by the exposure to the elements like rain, frost, and wind. Of course, friends, it's nothing but the weathering. What I intend to say is, mm, uh, uh, mm, for erosion to take up, it is weathering that should be initiated at that particular area, and without weathering or things that are related to weathering is happen, and erosion never takes place. So weathering first of all should takes place, and the activities which are allied with weathering should definitely taken up, so that there is scope for erosion to continue. Right. Um, Unlike glaciers and snow, which are confined to the cold and temperate latitudes, waves which act only on coastlines, winds which are only efficient in deserts, the effect of running water is felt all over the globe wherever water is present. So, running water is the most important single agent of denudation. Right, friends? Denudation is a very interesting and a beautiful aspect that should be covered in the ecology or in geography. Why? Because nowadays, due to scarcity of land and all, and keeping in mind the conservation of soil and the biodiversity, it is very much required to know about the things like weathering, the erosion, the denudation, etc. And in this process, dear friends, landforms formed by the running water. And regarding the river action, a river is a stream of fresh water or the overflow of mass of water that is larger than a brook or creek, and of course which being confined within banks and flows through a natural channel into the sea or into lake or into another river. And regarding erosion and transportation work of the rivers, here we need to know about things like the solution or corrosion. Friends, I repeat once again, the solution or corrosion, where most of the salts are removed from the bed rocks through the process of carbonation, right? The other one is abrasion or corrosion. Abrasion or corrosion. And this process involves the removal of loosened materials of the rocks of valley walls and valley floors with the help of erosional tools. And with regard to erosional tools, dear friends, we need not go into details about what the types of tools we have to take up the process of erosion, etc. Let us confine ourselves to the to these definitions and their brief notes only. And the other one is attrition. Attrition. Attrition is the process, I mean, the wear and tear of the transported material themselves when they roll and collide into another. Basically, just imagine, friends, when there is a water flow or a river is flowing. And generally, if we observe on the floor of that river or the basin, or so for example, that floor part, due to that density or momentum of water, boulders in some instance, it's all depending upon the acceleration, etc., or the flow of water, etc. Depending upon the speed or the pressure, boulders or rocks or small rocky particles, they also used to flow along with this river water. Sometimes what happens, and its course of water flow, the rocks also these two collide with one another, and in that process of collision, their sharp ends becomes rounded, or they take up different shapes, and colliding these rock particles or pebbles during the water flow, and that is called as attrition. That is called as attrition. I think I made it clear for you. Right. The next one is the hydraulic action. The next one is the hydraulic action. It involves the breakdown of the rocks of valley sides due to impact of water currents of channel. Right, friends? And regard to erosion and transportation work of rivers, we have dealt with four main important things in brief. Right, now let us move on to river and associated landforms. Now, the upper course. The upper course. Important landforms are generally V-shaped valleys, the gorges, canyons, rapids, and waterfalls. These are the things we can find in upper course. You can find in the upper course, and the middle or a valley course. The important landforms in the middle or valley course are the meanders, river cliffs, and slip of slope. Of course, interlocking spurs, etc. Interlocking spurs, etc. And next, the lower or plain course. The lower or the plain course. And important landforms are flood plain, the levees, artificial embankments, the most important one, Ox Bow Lake, the distributaries, the deltas, etc. Friends, these things are these landforms, associated landforms. Basically, I need to give a brief note so that you can understand what this upper course, middle course, and lower course means, right? While discussing about the course of a river, friends, we come across the upper or mountain course, which is generally in the stage of youth. That is, imagine a river in its youthful stage. And that youthful stage is generally called as the upper or the mountain course, wherein we can see the landforms like the V-shaped valleys, the gorges, the canyons, rapids, and waterfalls. And waterfalls. It is all because of the vertical corrosion only, my dear friends. It is all due to vertical corrosion, and the river is very swift and it descends the steep slopes, and the predominant action of the river is vertical corrosion. And the valley developed is thus deep, narrow, and distinctively V-shaped alphabet V shaped. Down cutting takes place so rapidly that lateral corrosion cannot keep pace. And in some cases, where the rocks are very resistant, the valley is so narrow and the sides are so steep that gorges are formed. The example is the Indus Gorge in Kashmir, and in arid regions where there is little rainfall to widen the valley sides and the river cuts deep into the valley floor, precipitous valleys called canyons are formed. Examples are the Bryce Canyon, the Utah in United States of America, right? And moving to this, the middle stream, dear friends, and middle stream here also we can come across with various things like the meanders, river cliffs, slip of slope, interlocking spurs, etc. And before entering into these things, dear friends, we need to discuss in brief what literally the middle or valley course, right? The middle course, of course, the lateral corrosion, it tends to replace vertical corrosion, which of course has taken up during the youthful stage, that is the upper course, right? Now it's time for the lateral corrosion, and it and active erosion of the banks. It widens the V-shaped valley. The volume of water increases with the confluence of many tributaries, and this increases the river's load. The work of the river is predominantly transportation with some deposition. Downstream, the interlocking spurs that project from both sides of the valley and cut back into a line of bluffs. Rain wash, soil creep, land slides, and gullying gradually widen the valley, cutting back the sides. The river travel, task of valley cutting, bed smoothing, and debris removal are being carried out in a more tranquil manner than in the mountain course, though the velocity does not decrease. Some of the load is dropped or deposited. Again, this depends on the volume of flow. Okay, right, friends. I think I need to explain what meander means. I'll give a one-line answer for that. So meanders are nothing but The irregularities of the ground force the river to swing in loops, forming meanders. This is a term derived from the winding river meanders in Asia Minor. And the mechanism of meander formation can be given in a illustration. Friends, I think it's time for us to conclude this session, and I will continue my next session with the lower or plain course. Right? Thank you. Hope you all enjoyed this session, and meet you in my following session with a good and interesting topic, that is the lower or plain course. Thank you. Thank you, one and all.